In the previous video, we completed some examples using those rules of logic, and we made valid arguments. So we used the patterns of reasoning called rules of logic, and the rules of logic involved given statements or premises and produce resulting statements or conclusions that were true. So if all the premises were true, then the conclusions must be true. Sometimes it can be really easy to incorrectly apply those rules of logic, and that's exactly what invalid arguments are. It's when you do not correctly apply. So we've made a mistake. We have a couple examples here of when someone has incorrectly applied those rules of logic and made a mistake and said something that's actually not true. So example number 1, x equals -4 only if x squared equals 16. X does not equal -4, therefore x squared must not equal 16. Now, I initially look at this and think of a counterexample, and that can be one of the first tip-offs to know that this must be an invalid argument, because I think, well, what if x had been 4? X squared then would equal 16. So there's something wrong here. Let's look at what they were trying to apply and how they did it incorrectly. So if we make this our P and this our Q, and we think about traditionally if P is true, then Q is true, this person had taken, okay, it's not P, and made the conclusion, therefore it must not be Q. What is wrong with that kind of application of the rules of logic? Well, it's like they're trying to do a direct argument. If P, then Q. P is Q, then Q is true. So it's like flipping it and saying, if P, then Q, not P, then not Q. But that is an incorrect way to apply the rules of logic, because we can think of all these, well, at least we can think of one other example where that doesn't work. So it's like, if x equals -4, then x squared equals 16. X is not equal to -4, but what if it was something else, like x equals 4 or something else? So we cannot make that type of statement, and that's an invalid argument. The next example is, if ABCD is a rectangle, then it is a quadrilateral. Okay, ABCD is a quadrilateral, therefore ABCD is a rectangle. Now, that also raises a red flag in my mind, and I think, well, what if I think of a counterexample? Okay, I know ABCD is a quadrilateral. That is my truth. That is my given. What if ABCD had been a square, or a parallelogram, or a kite? Then that's not a rectangle, because a rectangle is a figure with 4 right angles and 2 similar sides. Now, I guess a square could potentially be a special kind of rectangle, so maybe that still would be okay logic. But then we think about this parallelogram, those aren't 4 90-degree angles, so this is a great counterexample to show that this is an invalid argument. To make it more clear, let's break it down into our P's and Q's again. So if ABC is a rectangle, is our P, then it is a quadrilateral, Q. So we can say if P is true, then Q is true. The truth statement here that we're really focusing on is, okay, ABC is a quadrilateral. We know that. The conclusion they made was that ABCD is a rectangle. Now that is not correctly applying the direct argument rule or the indirect argument rule, because if you remember, the direct argument rule requires you to follow the arrow and always be in the positive. So if P, then Q, P, therefore Q. And the indirect argument required you to go backwards and flip it. So if P, then Q, not Q, then not P. So that is why this is an invalid argument, because it incorrectly applies the rules of logic, and there's a clear counterexample.